wanting to take the final if you don't have to. Okay, the ones that, because that is May 17th, that's an 8A. I will not be there to administer that exam because I've got my little 9th grade babies at that point. So I'm not going to be there when you guys are taking your final. So that's why I say if you, particularly for seniors, if you are wanting to take that final, you're not required to. I just need to know in advance that that's what you want because I have to send those tests down to guidance. And, you know, once we get past that, juniors who want to take the exam but don't have to, you just need to let me know that as well. Because I will not count you absent if you aren't here on that exam day.
You won't count us absent?
Cool. You're not required to be here. So, I mean, my fingers are crossed that my daughter passes all of her SOLs and that entire.
Last time I passed all my SOLs was 3rd grade.
So. Okay, so today we're going to be looking at thunderstorms and start talking about tornadoes a little bit. So one of the things that I want you guys to kind of think about and realize here is that we have 2 different types of thunderstorms. We have what's called air mass and then we have severe. So when we start looking at any kind of storm activity, we are going to refer to them as cyclones, and that really is just talking about circulation of air. We'll talk about a term like a mesocyclone, and that will be any kind of circulation within your tornado or within your supercell. But again, it doesn't matter about the size of them. We don't actually name these storms unless they're hurricanes, and they have to become tropical storms in order to get a name. If they're tropical depressions or anything like that, they don't get a name, but once they get a name, you keep it. Tornadoes are not named. We would be using the alphabet many times over if we named every tornado, so we don't do that. But when we start talking about thunderstorms, again, as I mentioned, there are 2 different categories that we put them in. And really, it's about the amount of time and the type of weather that you would expect. You're going to expect to have thunder, you're going to expect to have lightning, but the deal is with these air mass thunderstorms, their presence is short and sweet, whereas severe thunderstorms can last for a long period of time. And a lot of times with these air mass thunderstorms, you're not going to get hail, you're not going to get all of those things that you associate with normal thunderstorms because they're just around for a short time. They're in, they're out, moving on. Anytime we have thunderstorm development, we really have to have these, bless you, 2 things that are going on here. Unequal heating, and that really is like the localized convective lifting. We've got land that heats up faster than water does, and it creates pressure differences, which then creates instability in your air, which then causes it to rise and move on. Severe thunderstorms, these are really going to be along cold fronts. And that's why, again, being able to recognize the type of clouds that you're dealing with will be beneficial for you to know essentially the difference between a regular air mass and a severe thunderstorm that's coming in. We are already officially into tornado season. Thankfully, we haven't had one yet.
It was hail the other day.
Yeah, well, not out where I was, but yes,
It was
I know.
like 2 seconds if the rain started, it got faster. Then I looked out the window and I couldn't see anything.
Yeah.
And then hail started pouring. That only lasted like 2 minutes.
Yeah. And they were probably small. Yeah. They had mentioned the possibility of having gusty winds and hail and all that.
We had that last night.
Huh?
I had that last night.
You had that last night? Oh my.
Like,
It must have been, I mean, it was a little windy last night.
I thought I was about to get blown away.
I mean, it wasn't too bad. I don't know, I'm not in Orange County, so. All right, so with air mass thunderstorms, we have three main stages, and what you need to realize is that all three of these combined is about an hour's time. So again, those pop-up thunderstorms, if you're in Florida, this is what you have. That's all it is. It is not front associated. It is simply the convergence of those maritime tropical air masses. They come together, they rise, and this is what you get from it. So at the cumulus stage, this is really just where you get the building up of your storm. The cloud starts to build because you have strong updrafts only. Mature stage, this is where you have updrafts and downdrafts. You may get small hail, but this is not typical. This is really what we had the other day. It wasn't a severe thunderstorm. But this is what we're dealing with here. You may have some, some gusty winds here and there, but it really is more heavy downpours. And this mature stage only lasts maybe about 20, 25 minutes. Again, it's in, it does the thing, and it's out. The dissipating stage is all downdrafts. So any kind of moisture that's left in the cloud is dropped out, and after that, the storm essentially just moves on. It dissipates out. This is the different stage of look like. Again, cumulus stage, all building here. Notice just updrafts. That's all you're dealing with here. When you have your mature stage, that's where you have a nice even balance of updrafts bringing in the warm moist air, and the downdrafts taking the moisture out, being cooler and all of that. And then finally, the last stage is your dissipating. So all downdrafts. It's not pulling in moisture anymore. It is literally just dumping out all of that excess moisture. This is significantly different than what we have with severe thunderstorms. Severe thunderstorms are going to have these things associated with them. Heavy downpours, and I'm not just talking about for 20 minutes, I'm talking about for a long period of time. The possibility of flash flooding, and that really has to do with this. So we can get a ton of rain that comes down, and of course, it's going to start to go into your streams and rivers and all of that. These gusty winds, enough to down power lines, knock down trees, that kind of thing. Large hail, and that really means like marble sized or bigger. Not little bitty ones, not little pea sized, but large hail, so marble size or larger. Of course, the frequent lightning, and we'll talk about lightning and how that forms, and of course, the possibility of tornadoes. Anytime you have something like this, you are going to get some pretty intense weather associated with it. Tornadoes, of course, are just an added bonus, if you want to call them that. Now, the reason why we have some storms that are going to be around for a long time is really the fact that we have winds that are feeding it. We have the heat, we have the humidity, we have all of that moisture, but we also have this vertical wind shear. So we have a lot of advection movement of winds. Does everyone know the difference between convection and advection?
I know what convection is.
Convection is more of just your regular movement. Whenever you have convection, that's going to be more.
Just sweater.
Are you talking about like a passing storm or a storm that's like same?
Well, just in general, whenever we talk about convection and advection, there really are different types of movements. So the video I'm going to start showing you today, they talk about the fact that whenever we deal with tornadoes, there are really three kinds of movements. You have air that rises from the sides. And so you have all of this movement. And of course, in the mix of air rising, you're going to get the twisting. But you have all of this air that's doing numerous things. But whenever we talk about the convection part, that really is, and again, typically that's going to be kind of shown as this. That's typical convection. Advection essentially means horizontal wind. So it doesn't move up or down. It literally just moves in a horizontal direction. These are things that, like when we talked about fogs, that movement of air really is advection, where it comes in off the water and starts to cool and condense and produce those thick fogs like in San Francisco. Those are the types of movements that you have to worry about. these kind of wind shears, these advection movements, these are the kind of things that pilots have to be very aware of, because as they are either taking off or landing, if there are wind shears, it can actually cause the plane to go to the side and crash. So again, the day after tomorrow, what pilot is flying right into the middle of that cumulonimbus cloud? They don't do that. And the fact that there was turbulence, I'm not surprised. But you have updrafts and downdrafts, and there are usually multiple of these that are within one cloud. It's not just one and then the other. It's going to be multiple ones, especially if the cell is huge. Whenever you're flying, if your pilot decides to be daring, and sometimes they don't have a choice, they do have to fly through these clouds, but as they're coming in, depending upon, how high or whatever they're coming in, you may be caught in these updrafts and downdrafts. That's why the plane does this, and sometimes you're flying and all of a sudden it goes, ooh, and drops down. That's when everyone gets the barf bags out. And I'm like, please just don't.
No, they put their seatbelts on.
Yes, and we'll turn on the seatbelt sign so that you are buckled in, because otherwise it's going to be a little different ride for you. Huh? No, because again, those pilots don't typically fly through these type of clouds, because the turbulence actually, if there are wind shears that are present in this cloud, it could cause the plane to crash. So they tend to avoid these. Again, the pilot's like, hey, big old cloud, great, let's go in. In the movie. Not normally.
There's a Key and Peele skit where they went into a cloud and then they did fasten seatbelt, but one of the actors,
Were they all over the place?
one of the comedians and he was hitting the roof of the
Oh yeah, I can see
cabin.
that. Yeah. But that's why they don't typically fly through these. Again, it's obviously not a very pleasant ride for the passengers. But there are a lot of things that they're not really sure what's going on inside this cloud, and if there is this, or even if there's a really strong downdraft, it can cause the plane to fall. It can literally almost like pushing down on a can. So, again, your ride would be a little different if they did that. So a lot of times they'll just ride up here. They'll ride in the lower stratosphere. But these are the kind of things that you have to be aware of, and even though it is oftentimes aggravating when you're flying out in the summertime or when it starts getting warm and you have a delay because there's storms going on, that's why. They're not trying to disrupt your trip. They're really doing it for your safety, because they aren't necessarily sure if, especially during takeoff and landing, whether there could be a wind shear, there could be a microburst. And microbursts don't necessarily have indicators on Doppler. They're just strong downdrafts.
Those tend to happen right here a lot.
Yep. And they tend to happen Route 1 and east.
Why is that?
Because it's flattened out. And it's easier for circulation to begin and for those clouds to build. That's why we get a lot of tornado activity that's, along 95, Route 1, because it moves from being rather hilly, like where we are here, to being pretty flat out towards the northern neck and all of that.
And because they cut down a lot of trees.
Yes, and the trees do help with a bit of the wind shear, but a lot of it though is the topography. When you look at places like the Midwest, they've got trees, they've got all that kind of stuff, but it is so flat. If you've ever driven across Kansas or Nebraska or Oklahoma not as bad, but Kansas, it just looks like a sea of corn. That's all you're seeing. You're like corn, 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 road, corn, 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 corn. Oh, farmhouse, corn, corn, corn. That literally is your entire drive.
That's how it is to Ohio.
To get to the other side of the state so you can hopefully change the scenery a little bit. But, whenever you start having topography and again with with the Midwestern states, they have the maritime tropical, continental polar, and the continental tropical that's coming in. So they have the convergence of those three air masses, powerful because they are warm, and warm air just naturally wants to rise and becomes unstable anyway. So, but like I said, with Virginia, we are kind of fortunate in that, at least where we are anyway, we don't have precipitation is going to fall. This is also where it will be present in this area where the cold air is. Okay. This is just a picture. We've actually had these here. We've had these roll clouds. This is out front of a developing supercell. Hopefully that plane's not going anywhere anytime soon. It's probably not the best time. But what you're looking at is, this is the front of your cumulonimbus cloud, and this cloud is right out front. And it literally is like a same kind of thing. And in this case, you've got a lot of turbulence where the air is coming and you create this turbulence out front, and it's like a Swiss cake roll, just rolling around, developing that roll cloud right out front. That's supercells. Again, they are huge. Again, 12 to 30 miles in diameter. They do persist usually for a long time. But the thing that makes them different than just a regular severe thunderstorm is the presence of this mesocyclone inside. So this is why whenever you get a tornado warning or a watch even, I would recommend not only that you keep an eye on the sky, but you keep an eye on the fact that it may rotate. If it starts rotating, you need to get inside. Because if this thing is rotating, that means you have a mesocyclone inside, that column of rotating air. And if you have that, the chances are better for worse. The video that I'm going to show you, I won't be able to show you the whole thing today, but you'll get to see what a supercell looks like as it starts to develop. And of course, you'll see it growing bigger and bigger, but you'll also see the lattice cloud start to develop with it too. Anytime, this is why we get supercell development later in the afternoon. There's a lot of heat that builds up throughout the day, and not necessarily localized convective lifting, although that can help the build, but it really is all this warm, unstable air over the land that rises up and gives rise to your cumulonimbus clouds, and of course then your supercell. So that's why you typically have any kind of tornado activity, supercell activity, is going to happen late afternoon and evening. You can still have them in the night. You can still have them in early morning. If it's warm enough outside, you can still have them even after it's dark. But that's not typically when they're going to show up.
It was 106 degrees in Chesterfield and nothing happened.
Well, it's not just the fact that you have 106. I mean, it can be plenty warm. Did you have a pop-up thunderstorm?
Yeah.
That was just nature's way of saying, "Ooh, let's cool it down a little bit, calm everything down." But yeah, I mean, you can have it warm like that, but it's a lot of times if it can easily get away with just a pop-up thunderstorm, just an air mass thunderstorm, then that's what will happen. But those things, supercells, and that they really are associated with frontal boundaries, cold front boundaries. Now, anytime you have what's called a squall line, these are just a row of supercells that move in kind of like a united front and bringing the severe weather along with it. They can, of course, persist for a long period of time, 10 hours or more, and they do have the Momata sky, so that's what you start to look for. The dry line, remember we talked about the dry line before? Do you guys remember what that marked the boundary between? What two air masses?
Hold them, I don't know.
Do you guys remember what the dry line marked the boundary between? Continental tropical air and continental tropical and maritime tropical. It's not really a front, but it does mark the boundary between these two things, and that's typically where we're going to get squalls or squall lines. So anytime we have, and this is where we are right now as far as timing, we have this warm, dry air that's coming in from Mexico, warm, moist air that's coming in off the Gulf, and that dry line, this is where you can expect to find squalls, or squall lines, is right along that boundary. And storm chasers, that's what they'll look for. They'll look for these kind of line of supercells that start to pop up, and they'll talk about that they're forming along the dry line. That's how you can see where it is. It's not a frontal boundary per se, but it is that boundary between those two air masses. These mesos, they will talk about them in the movie Twister. The mesoscale convective complexes are not just supercells, but they are huge. And I've put a comparison there for you for how big a meso can be and how that compares to the size of Virginia. So you can see how big they are. They're about the size of a state. And that's one storm. But we don't typically get mesos here. Again, we really don't have the topography for that. We really don't have the convergence of those different air masses to create that scenario for us. So we just don't really get them, thankfully. But this is what they look like on a Doppler, on a satellite. Notice that this cell right here, this is a very developed meso. And you can see if we kind of pulled it down a little bit, it would be about the size of South Dakota. That's what this state is here. Or we can make it North Dakota. I don't care, whichever one makes you happier. But do you notice anything about this cell?
It has a tiny dot in the middle.
It does have a dot in the middle. Whenever you get red next to purple or blue next to red or anything like that, that is showing you that winds are coming in and they're going away. So moving in and doing this. Anytime you see that, that tells you there's rotation. And in fact, what that's marking is the location of the major mesocyclone inside your mesoscale convective complex. That's what it's showing you. So chances are really good that there's a tornado on the ground. Now this is where obviously satellite and technology is limiting because we can't see everything on the ground. They have weather spotters, they have observers that are on the ground, and they will work with them to figure out whether there really is a tornado on the ground, and how big it is, what the wind speeds are if there's a tornado, and of course do a projected path. Typically, they start from the southwest and go to the northeast. That's their typical path. And so this one here is going to, be right here in South Dakota and just kind of move in this direction. So, and that's Minnesota, right? Minnesota, Wisconsin.
I don't know my 50 states. I just know Kentucky over.
Yeah, right here.
I haven't memorized that.
But anyway, this is the direction. So, and you can see little cells that are popping up here. There are a couple in here. There's another one right in here. Ooh. So they all develop that funnel within it.
Oh, it's so pretty.
Now, the last thing I want to go over with you guys today deals with lightning. And this one is always kind of interesting because when they started trying to figure out not only how hail formed, but they really wanted to figure out how lightning was generated within a cloud, because most of the lightning, in fact, 80% of the lightning that's produced is within the cloud itself or between one cloud and another one. Only a small percentage, only 20%, actually hits the surface, which is a benefit for us, obviously. But whenever they started to try to figure out again why the lightning was produced, they had to go back to something kind of simple, and that was the movement of the ice nucleus within the cloud itself. And what they realized was that whenever we had the movement of that, let me get to the picture. The picture's going to be easier. whenever we had the movement of that ice nucleus within our cloud multiple times, it actually generated charge differences in our cloud. And so here we get a buildup of negative charges, and positive charges tend to be up towards the top part of our cloud. On the ground, and this is why, again, a lot of times the lightning is within the cloud itself or between one cloud and another. But there are times when you have a lightning strike that hits an object on the ground, whether it's you or a tree or a car or whatever. Anytime that happens, there is what's called a step leader. That was one of your terms. A step leader that comes out of the base of your cloud and is looking for a match. Well, honestly, for the longest time, they thought that lightning went from cloud to ground. There was no discussion, no need to even have another study done. It's kind of like they found out that the speed of a tornado is different right at the ground and just above the ground. They actually learned that from the TIV, the Tornado Intercept Vehicle, because it drove into a tornado. But let's just take, we'll do a tree. That way it's not quite as